Welcome back to Notes on Tuesday, April 14th, 2020. Today we're moving on to a new chapter. We're going to chapter 9.1. It's all about circles and circumference. So we've already talked about circles previously, but this is going to be a more in-depth look at a circle. The definition of a circle. It is the set of all points in a plane equidistant from a given point called the center of the circle. So if I was to start right here with center, and I'm going to call that K, and I was to draw the set of all points that are equidistant from K, and I say that that has a radius of 2 millimeters. So that would be circle K, everything in the blue. So what I just gave you was a special segment of a circle, and that circle is what we call the radius. So a radius is a segment with endpoints at the center and on the circle. So from the center to a point on the circle, that's what we call the radius. There is a special notation for this circle. Since I called it center K, you would draw this with a dot in the middle and put K, and that is read as circle K. So whenever you see a circle with a dot and then a capital letter after, that lets you know the name of that circle. If you look in our box about special segments, I've got another special segment, and that is what we call a chord. And it's not what you play on the guitar or piano. A chord is a segment with endpoints on the circle. So if I come over here and take a look, I got point A, I got point B. Segment AB is what I call a chord. So again, segment AB is a chord. If you look right here, I got segment D to E. There are 2 endpoints on that circle, and DE is a chord of circle C. DE is special. It is the longest chord, and that is a diameter. So a diameter of a circle is the longest chord. So if you really want to know this, the longest chord is the diameter, and that is simply a chord that passes through the center, and it is made up of collinear radii. So as long as I have 2 endpoints on my circle and I go through the center, so right here, that is diameter. So let's get to our examples, shall we? Example number 1, you're going to have to look over here at circle E. It's kind of hidden over here to the top right, but here's example number 1. There's circle E. It says, name the circle and identify its radius. Well, I just named it. I just gave it to you. It is circle E. So I would just put circle E and the radius, and just identify a radius. Well, in order to be a radius, remember I have to start at the center and go to a point on the circle. So I could say right here that segment EB is a radius, or I could say segment ED. That is also a radius. It starts right here, point E, ends at point D. That would be a radius. Example number 2, I need to identify a chord and a diameter of the circle. Well, there are 3, if you would, chords here. I've got WZ. WZ is a chord. I've got WY. That is a chord. And then I've got XZ. That is a chord. And 2 of these are diameters. That would be WY, and that would be segment XZ. Those are chords. Diameters. Name a circle and identify the radius right here for example number 3. That's down here in the bottom. So I look, the name of this is going to be circle F. That's the center point. There is a radius in here. There are 3 of them. You could say FA. You could say segment FT if you wanted. Or you could say segment FN if you wanted. All 3 of those are radii of the circle. Which one of these is not a chord? And that would be segment FN. That would be not a chord. FN is definitely not a chord. If you wanted to say any of those radii, you could see that those are not chords. By definition, the distance from the center of a circle to any point on the circle is always the same. Therefore, all radii r of a circle are congruent. And because the diameter is composed of 2 radii, all diameters of a circle are also congruent. There are some special formulas that we know. So if a circle has radius r and diameter d, the following relationships are true. The radius is equal to diameter over 2, or the radius is 1/2 times the diameter. If I look at the diameter formula, I know that the diameter is twice the radius. That's just what we said right here by its definition. So in example number 5, if I look and I know that r to t is 21, what is the length of QV? So what you need to know is that QV is a radius. So QV is a radius. I also know that RT is a diameter. So I'm going to start off with the diameter formula. I'm going to say that 21 is equal to 2 times the radius, because I need to find the length of a radius. So in order to get the radius, I know that 21/2 is my radius. And you guys don't like to write 21/2. 21/2 is 10.5. So the radius is 10.5 centimeters. Example number 6. If I was to look, it says that QS is equal to 26. What is the length of segment RV? Again, RV is a radius. And I know that QS is a diameter. So again, I'm going to need to use the diameter formula and say that the diameter is equal to 2 times R. In this situation, 26 equals 2 times my radius. I divide both sides by 2, and I get that 13 is equal to my radius. So 13 centimeters is RV. So as with other figures, pairs of circles can be congruent, similar, or share other specific relationships. So 2 circles are congruent if and only if they have congruent radii. So here I have circle G, I have circle J. The only way for circle G to be congruent to circle J is if the radii, GH, is congruent to segment JK. So that's the only way for my circles to be congruent. It is true that all circles are similar. So here I have circle X and I have circle Y. Circle X is similar to circle Y. Again, all circles are similar. And the other special property are concentric circles. They are coplanar circles that have the same center, but they will have different radii. So here I have circle A, which has a radius for AB. I also have circle A with a radius of AC. So if you were to think about this as maybe a car rim, you could see that this would be the rim, and then this would be your tire that goes around your rim. Maybe you're playing darts. You have the concentric circles when you play darts. So cornhole board, you guys are familiar with that. This would be the hole, and this would be that little ring that's painted around the hole on the cornhole boards. So those are just some properties here. Let's take a look at our first example. It says the diameter of circle X is 22 units. And the diameter of circle Y is 16 units. And I know that WZ is 5 units. So the distance from there is 5. All right. So first off, it says that the diameter of circle X is 22 units. So the diameter is equal to 2 times the radius. Then that means 22 is equal to 2r. So 11 is equal to the radius. So that means that the distance from X to Z is 11. And we know that the distance from Y to W, right there, is going to follow the same. It is 16 is equal to 2R, so that means 8 is equal to R. So that means this distance, YW, is 8. So it says, I need to find the distance from X to Y. So thinking back to what we learned early in the year about the segment addition postulate. If I say xz plus zy, that equals xy. So I'm going to write that down. Xz plus the length of zy equals xy. But there's a problem. I do not know the distance from z to y. So I could write another segment addition postulate. I could say that WZ plus ZY equals WY. And that's the equation I want to start with. So again, I'll repeat. If I say WZ plus ZY, that equals WY. So I'm going to go on and fill in what I know. And I know that WZ was 5. They told me that. Plus ZY, that equals WY, which is half of the diameter, which is 8. So that means ZY equals 3. Now I'm ready to rock and roll because I know that XZ, we found that, is 11. So I say 11 plus ZY, which is 3. That equals XY. And that means that 14 equals XY. Looking at our next example, it says that the diameters of circle D, B, and A are 4 inches, 9 inches, and 18 inches respectively. Find the length of AC. Well, if the first diameter is 4 inches, that means that the length from D to C is half of 4, which is 2. That also means that the radius for circle B is 4.5 inches, because that's half of 9, so that would be 4.5 inches. And then it says that the radius for circle A is going to be 9 inches. So from A to E, that is 9. That also means the distance from A to D is 9. So they want me to find what is the length from A to C. So I need to find what AC is. That is unknown to me. Well, I know that DC is equal to 1/2 of 4, which we already said is 2. So I'm just going to write it. DC is 1/2 of 4, which is 2. That's going to be helpful because now I need to find the length of segment AC. So I could write the following, that AD is equal to AC plus CD. And I was told that the radius is 9 from A to D. So 9 is equal to AC, which we don't know, and we just found that DC is equal to 2. So here we go. Subtract the 2, so we get 7 is the length of A to C. The circumference of a circle is the distance around the circle. By definition, the ratio C circumference divided by the diameter is an irrational number called pi. 2 formulas for circumference can be derived using this definition. So if I look, the circumference divided by the diameter is pi. If we multiply both sides by the diameter, we get that the circumference is pi times the diameter. Using the substitution for the formula from the previous page for the diameter, because the diameter is twice the radius, we get that the circumference is 2 times pi times the radius. So here are our 2 circumference formulas. A series of crop circles was discovered in Alberta, Canada on September 4th, 1999. The largest of the 3 circles had a radius of 30 feet. Find the circumference. So if the radius is equal to 30, I'm going to use the circumference formula involving the radius. So C equals 2 times pi times the radius. So that is 2 times pi times 30. Now I'm just going to take and multiply 2 times 30, and I get 60 pi feet. That's an exact answer. So I could write my answer as 60 pi feet, or I could approximate what 60 pi feet is on my calculator. And that is about, and if I say I want to round that to the nearest tenth, 188.5 feet. That is the distance around. The Unisphere is a giant steel globe that sits in Flushing Meadows Corona Park in New Queens, New York. It has a diameter of 120 feet. Need to find its circumference. So the diameter here is equal to 120 feet. So I'm just going to use the circumference formula that involves diameter. Circumference is pi times d. So that means circumference is pi times 120, which we get as 120 pi feet. So again, I could write my answer as 120 pi feet. That is an exact answer. But if I just do 120 pi on my calculator, I get that is approximately 377 feet. Find the diameter and the radius of a circle to the nearest hundredth if the circumference of the circle is 65.4 feet. So we're just going to use one. I'm going to find what the diameter is first, because once I know the diameter, then I could use the diameter formula to find the radius. So 65.4 is equal to pi times d. So in order to solve this, I divide both sides by pi. So on my calculator, 65.4, I'm going to divide that by pi. And it's going to be a nasty number. I'm going to get 20.8174. That is what the diameter is equal to. So let's just say we're going to round our answer to the nearest tenth. So that means 20 point, it says to the nearest hundredth. So that's going to be 20.82. So now how do I find the radius? I'm going to say 20.82 equals 2r, because that's what the diameter is. Divide this by 2. So 20.82 divided by 2 is 10.41. And lastly, example number 12, it says find the radius of a circle to the nearest hundredth if its circumference is 16.8 meters. So 16.8 equals 2 pi r. So I need to get the radius by itself. So here I'm going to divide both sides by 2 pi. That will give me the radius by itself. So 16.8 divided by 2 pi. And again, they want me to round this to the nearest hundredth. So I'm going to get 26.389 is equal to the radius. So that means the radius is 26.39. And that's in terms of meters. The previous problem number 11, that was in terms of feet. So I need to put that unit of measurement. That's it for page 4. Okay, if I'm given a circle, I could find the exact circumference of circle K. What you have here is you have a right triangle, and you know that the radii are congruent. So now what we have is we have a 45, 45, 90 right triangle. We have an isosceles right triangle. And we know that 3 square roots of 2 is equal to r square roots of 2. So what is the radius? I divide both sides by the square root of 2, and I get that r is equal to 3. You could set this up as a Pythagorean theorem problem, but your life's a lot easier when you use special right triangles. Here, again, I have a 90-degree angle. I'm going to show you on this one what it would be like if we use the Pythagorean theorem. So this is r, this is r. So what do I have? I have r squared plus r squared is equal to 10. Pardon me. And they asked me to find the circumference. So I'm going to go back to the previous example. If r is equal to 3, I'm not finished because circumference is equal to 2 times pi times 3, which is 6 pi. I'm sorry, I got ahead of myself. So that is the circumference. So now I'm going to go back. It says find the exact circumference of circle B. So I've already established that the legs are r and that the hypotenuse is 10, so that's 10 squared. So I get 2r squared is equal to 100. Now I'll divide both sides by 2. So I get r squared is equal to 50. Now I need to take the square root to solve for r. So I get r is equal to the square root of 50. And this is where we're going to have to remember some of our skills. So if I know that r is equal to the square root of 50, that means the square root of 50 is equal to the square root of 25 times the square root of 2, which is equal to the square root of 5 squared times the square root of 2. And remember, the square root is undone by that power, which is being squared. So I get 5 square roots of 2 is my radius. So r is 5 square roots of 2. So now what is the circumference? Circumference is equal to 2 times pi times my radius. That is 2 times 5 square roots of 2 times pi, which is 10 square roots of 2 pi. And that is my final answer. So I hope you guys found the notes to be Pretty helpful. Make sure you check Schoology for your homework assignment. Thank you.